Welcome back. Today we're going to start our first day of applications for quadratics. So whenever you're thinking of the quadratic applications, think of the phrase, whatever goes up must come back down. So if we kind of picture a graph for a minute and picture that you're throwing a ball. Here's your ball. It's starting right here. It's coming up and it comes back down. If we kind of use that as a guide, there's some key questions that you're going to be asked working with quadratics. The first thing that you might be asked is, how long does it take to get to the maximum height? Well, it's asking for the x value of the vertex, and so you would be using the opposite of b over 2a. This chart here really is going to be your key to use to study, so that way you know how to answer the questions. If it asks you what is the maximum height, again, oops, sorry about that, it's asking what is the y value of the vertex. So you have to substitute in the x value of the vertex to get the y value. Then it will ask you questions like, well, how long does it take? How many seconds would it take to reach whatever it is? So that's where you have to set the equation equal to that height, whatever that height may be, and then solve it for 0 and use the quadratic formula. How many seconds does it take to reach the ground? Well, that one's easy because the equation is set to 0 then, because the ground is at 0 feet. And again, you use the quad formula. The final thing it might be talking about when we're looking at these is whatever object it is, whether it's a ball, a textbook, whatever the case, a football, is it being launched off of a building or a cliff? Well, that's just talking about the y-intercept. That's when you substitute 0 in for x and solve for y, or remember, it's just looking at the c value. Okay, that would also tell you that answer. So let's go ahead and go through an example on how to do this. Ellie was tired of having so many books that she never uses in her locker. Think of your math textbook. She decided to throw her math book off of a cliff. The situation can be modeled with the equation h of t is equal to negative 16t squared plus 96t plus 112, where h of t is equal to the height in feet and t is the number of seconds. So the first question we're asking is, how long does it take to reach the maximum height? So if you go back to that little chart on the front page, it says, how long does it take to get to the maximum height? So that means that we will be finding the x value of the vertex. So this is where you want to go ahead and identify your a's, b's, and c's to start with. So what is a equal to in my equation? Good job, negative 16. B is equal to, great, 96. And C is, awesome job, 112. So how long does it take to reach that maximum height? We're going to be using that formula, the opposite of B over 2A. So if B is 96, what's the opposite of 96? Good, negative 96. All over 2 times, what's your A value? Negative 16. Good. So now in your calculator, you're going to on paper, you're going to write negative 96, but in your calculator, you're going to do 2 times negative 16, and what does that give me? Awesome, negative 32. Now we can go ahead and divide out this fraction. And in this situation, decimals are okay if you come up with them. But here, negative 96 divided by negative 32 is what number? Good, it's 3, and it's asking how long, so it's talking about seconds. So 3 seconds, this textbook will reach its maximum height. So if you kind of think about a little picture here for a second, here's my graph. We have a textbook. Here's my textbook. There's an M for math in it if you can kind of see that little writing. Sally's over here. Here's Sally. And she's taking her textbook and she's throwing it. And eventually it will hit the ground. What we want to know is, when will it reach the highest point? So right here is the highest point. So this is at 3 seconds. That's when it will reach the highest point. Now, the next question we want to know is, what is the height of that book after 3 seconds? So it says, what is the maximum height? Well, that's where you substitute the x value in. So you're going to substitute the x value in. So if we go back here, we're going to take that 3 and we're going to substitute it into our equation. So our original equation is negative 16t squared plus 96t plus 112. So now what we're going to do, everywhere we see a t, we're going to put a 3 in for it. Kind of like when you had to do the graphing. Let's see here. It's 3 squared and 3. And we can enter this exactly as it appears into our calculator. You can go through and do it the long way with your mental math, but because these numbers are so large, it's more efficient to use your calculator. Oops, this should be 112. Sorry about that. All right, so when you punch it in the calculator, what do you come up with? Good, 256, and we said this is measured, 256, and we said this is measured in feet. If we go back to our picture over here, so it's 3 seconds is the maximum height and 256 feet. Great. So my next question is asking us, how many seconds does it take the rocket? What am I saying here? That should be a book. That should say book. So how many seconds does it take the book to reach a height of 192 feet? So now we want to know, when will that equation be equal to 192 feet? So you start with your original equation, negative 16t squared plus 96t plus 112, but now you're going to set it equal to 192. But before we can do the quadratic formula with this, you do need to make it so the equation is equal to 0. So how do I move that negative 192 to the other side? Good job. I'm going to subtract it. So when I do that, I get a negative 16t squared plus 96t. What is 112 minus 192? Good, 80, but negative. So minus 80 equals 0. Now that I have my equation equal to 0, I can identify my a's, b's, and c's. So a is equal to negative 16, b is equal to 96, but now c is equal to what number? Good, negative 80. So from here is where we jump into our quadratic formula. So whenever we're trying to figure out how long it takes to reach some kind of height, we're always going to use the quad formula. You start by doing the opposite of b. So if b is 96, the opposite would be negative 96, plus or minus the square root of b squared, so 96 squared, minus 4 times my a, which is negative 16, and my c, which is negative 80, all over 2 times my a, which is negative 16. Okay. Now we need to go ahead and simplify the numbers that are under the radical and the denominator. Negative 96 plus or minus the square root. And we're going to actually punch in all of that stuff under the radical. And tell me what number you come up with. Or say it out loud. Nobody's looking. Good. Did you get 4,096? Awesome job. All over negative 32. So now that I have that number, I'm going to tell you some exciting news. We do not have to worry about breaking down our radical. We don't have to worry about exact and approximate answers. All we're going to do from this step now is do our plus equation and our minus equation and find our decimal answers. So we split this into our two problems. Negative 96 plus the square root of 4096 over negative 32. And negative 96 minus the square root of 4,096 over negative 32. So let's go ahead and punch them into the calculator. Remember, if you want to follow along with me as I punch it in, feel free to. Negative 96 plus the square root of 4,096 equals, now divided by negative 32. Did you all get a positive 1? Good. Now we're going to go through and do the negative equation. So negative 96 minus the square root of 4,096 equals, divided by negative 32. And then the other answer is 5. Notice I got two answers here. It wants to know how many seconds will it take for that book to reach a height of 92 feet. So the answer would be 1 second and 5 seconds. Now, some of you might be sitting there thinking, how is that possible? If we go back to our graph, what it's asking us, 192 feet, say, is about right here. Let's do this in a different color. We'll do it in yellow. So say 192 feet is right here. Or I guess it has to be down here a little bit more. So say it's over here. It hits here, and it hits here as well. So notice it hits my graph 2 times. So that's why we have 2 different answers for it. All right, the next question is asking us, when will that book hit the ground? So how high up is the ground? Right, it's 0 feet. This one's nice and easy because we're just going to take that equation that we started with, the negative 16t squared plus 96t plus 112, and set it equal to 0. So again, what do we need to do to use the quad formula? You guessed it, your ABCs. So what is A equal to? Negative 16. B is equal to 96. And C is equal to 112. Great job. Now we're going to go through and again enter it in our quadratic formula. So it's going to look really similar to the equation above, only notice our C value is different. So again, what's the opposite of B? Great, negative 96 plus or minus the square root. Sorry, the colors kind of merging together. And we're going to do B squared, so 96 squared, minus 4 times A, which is negative 16. And now B, which is 112, all over 2 times A, which is negative 16. So go ahead and try to enter those numbers into your calculator. And let's see if we get the same answer. Did you get 16,384? Good, that's what you should have gotten, over negative 32. And again, like I said, the nice thing here is we do not need to break down these radicals. All we want are our full answers, our decimal answers or whole number answers. So we're going to break it into our two equations, negative 96 plus the square root of 1,600,384, or I'm sorry, 16,384 over negative 32, and the minus, negative 96 minus the square root of 16,384 all over negative 32. So again, if you're unsure how to enter it, you can follow along with me as I enter it into my calculator. So I have negative 96 plus the square root of 16,384 equals divided by negative 32, and I get a negative 1. Now I'm going to go through and do that one more time. So negative 96 minus the square root of 16,384 equals divided by negative 32, and I get a positive 7. So notice I get negative 1 second and 7 seconds. So hold on a second. Let's think about it. Can you have negative time? No. So the only place that that book would be hitting the ground is after 7 seconds. So if we go back up to our little graph here, notice here's the blue dotted line telling me where that book is going. Right here is where it hits the ground. This is hitting the ground. So this is where that 7 seconds appears. The negative is over here, but it never started on the ground here because it started from Sally here holding her textbook that she didn't want to see anymore. The final question that it's asking us is, based on this equation, was the book thrown off the ground or a cliff? So if you go back to the other page and we look at the bottom box, it talks about, was it thrown off of a cliff or from up high or whatever, or the ground? Remember, we're looking at the C value. So if we think about our equation, the C value in our equation is 112. So C is equal to 112. So that means that my y-intercept is equal to 112 feet. So was that off of the ground or a cliff? Well, it would be off of a cliff. The reason being is because it was thrown from an initial height of 112 feet. All right, so I feel like you guys, if you watch this video, you should be good to go to start working on some classwork. Definitely use the first page of the notes that we went through to help guide you through how to do each step that it's asking you to do. If you have any questions at all, feel free to reach out to your teacher. Otherwise, thanks and have a great day. Bye.